In this very short video, I'm going to explain the critical value to you. If you are asked to use a p-value, you simply use the calculator and the pre-programmed tests in there. But let's say it's a critical value problem proportion Z test. That's section 10.2. Let's say you have a p equals 0.35 and you're testing that p is less than 0.35. X is given to you 117, N is 380, and the level of significance alpha is 0.05. So if you're using critical value, here's how you do it. The next step is to find the test statistic Z. You can simply use this formula or use the calculator, which I will show you in a second. If you use this formula, you need a p hat. P hat is a proportion from the sample, which is 117 over 380, which is 0.31. Minus p, which is the assumed value in the null hypothesis that's assumed to be true unless proven otherwise. P is 0.35. Q is the complement of p, so it's 1 minus 0.35. And N is the sample size, which is what? 380. If you do your math, and this is alone separately, here's what you could do. You could have done this on the calculator, so let me show you. You go to tests, proportion Z test. Let's focus this a little bit. Proportion Z test. You put 0.35, X is 117. I put the values there to speed up the time. And then you need less than, and then calculate. So you get Z is negative 1.72, and you get the p-value, which is 0.0426, which is less than alpha. You reject HO, but he says he wants you to use the critical value. So you can only use the calculator to get Z, which is negative 1.72. Let me explain the critical value to you. Okay. The critical value approach is to find the value that splits up the rejection region from the non-rejection region of HO. Now, why the rejection region here? I shaded on the left because I have a less than. So if you have a less than, you shade on the left. If you have a greater than, you shade on the right. If you have a two tails not equal to, it will be on the right and the left. And here's how you find this critical number, and I'll show you how to use it in a second. Okay. This area that you shaded is alpha. It's always alpha, whatever alpha is given in the problem. So that's 0.05. You need to find this value here such that the area to its left is alpha. You can use a formula which is called inverse norm. You put this alpha value here, 0.05, and you put comma 0, comma 1. This is going to give you negative 1.645. So this critical value is negative 1.645. The area to its left is the rejection region where you reject the null hypothesis. This is 0 right here. This is the center, 0. Okay, here's how you make a decision to reject HO or fail to reject HO. You bring the step 2 answer, which is negative 1.72. If I put negative 1.72 on the number line, would it be to the right of negative 1.645 or to the left? Well, actually negative 1.72 is less than negative 1.645, so it is to the left. Well, since it is to the left, it turned out that it falls in the rejection region, so then you reject HO. Let's suppose this value was negative 1.23. It will be somewhere here, then you will fail to reject HO. So this is how you make a decision, and that's why it's important to find the critical value, which is splits up the rejection region from the non-rejection region. Now, one thing I'd like you to know here, if P was greater than, for example, then you will shade here to the right and find alpha. You can do an inverse norm, 0.0501. It's going to give you negative 1.645, but because this is a right tail test, so you change the negative 1.645 to positive 1.645. So you can still do the same thing. The only difference is when you have a two tail test, let's say this was different from. So here's what you have to do, guys. This alpha, you have to split it up on two regions. So each region will take half of alpha, which is 0.025. So you get 0.025 here and 0.025 on the other side. And then you run inverse norm 0.02501. you will get an answer. I think you will get negative 1.96. So one critical value will be negative 1.96 and the other critical value will be positive 1.96. I'm going to create another video, critical values for the t-test, but this is only for the proportion test.